This is Ronit from MathX, and today we're going to be doing number 24 from the 1st and 2nd grade Math Kangaroo of 2019. Now, this problem, in my opinion, does not deserve the place of 24 because we can solve it easily through the concepts we're going to learn today. So without further ado, let's get started. Amalia's machine converts one red token into 3 white tokens and 1 white token into 2 red tokens. And then it shows the machines that do this process right here. And Amalia herself has 3 red tokens and 1 white token. She uses the machine 3 times. What is the smallest number of tokens she can have at the end? And the answer choices for this problem are A, 7, B, 6, C, 8, D, 5, and E, 9. Now, to start the solution of this problem, we'll be writing variables for these because we can't just have these variables as circles. That would be hard to draw. So let's just convert them into reds and whites. R for this reds and W for these whites. So let's quickly just write them right now. Okay, so I wrote down the variables as R, and W. So next, we'll be analyzing these machines. So we notice here that a white conversion will transfer into 2 red tokens, while a red conversion will transfer into 3 white tokens. So we need to be using the white to red transfer as much as possible. And with that in mind, we can start writing it out separately. So let's start that right now. Okay, so I wrote the variables here again because we're going to be writing here instead of here. To start this off, we'll be using the transfer from white to red, or W to 2 R's. So let's just draw that out real quick and get this. Okay, so we got this. And we have to cancel out this W since the W for white is now transferred into 2 R's. But next, we have to use this machine of red to white conversion. So we'll also be drawing that now. Okay, so we got also the red to 3 whites conversion. But we also have to cancel out this red since we used it and converted it into 3 whites. So let's just cancel it out right here. Okay, so final step. For our third time of using the machine, we'll transfer the white again into 2 reds, repeatedly so as this. So let's just quickly do that right now again. And we've finally finished the model. So the model shows here, as we're going to be explaining now, that we have the 3 R's and the 1 W. But we turned the 1 W into 2 R's, but we had to also cancel out the W for that. And we cancel out R because we transferred that R into 3 whites, as the machine will show here. And then we canceled finally for our third use of a machine for 1 W into 2 reds. Now let's count out all of the letters remaining, since we also cancel out this one, and this one. So that's 3 canceled out. But without further ado, let's just start counting it, and with that, we'll get our answer. Okay, so we got 1 red, so let's just circle that. Another red, so that's the second one. Third, and then we have another red here, because this red from here was not used up, so it stayed there. And we got 4 so far. And now we got a W, which is the third. And we got another one for a second W. And then we finally got the 2 R's. And when that's all added together, we get 8. So the answer choice C is for this problem. So as you see now, we're now officially finished with this problem.